It's one of the most common construction materials in the world. Cheap, strong, and easily made, concrete allows cities to reach the sky, levees to hold back floodwaters, and roads to stretch across the land.
We're pouring the concrete in a double T form, which is a parking garage product.
Concrete technology dates back at least as far as the ancient Romans. And today, at places like the Unistress Corporation in Pittsfield, Massachusetts, where Rick Petricca works, it is still mixed with the same three basic ingredients: water, a cement binder, and gravel.
When we mine this from the earth, it's in the hillside. It's actually made up of boulders, cobblestones.
On its surface, concrete hardly seems the stuff of innovation. But in fact, it's an example of how the innovation process sometimes works, whereby a scientist, engineer, or inventor makes an important discovery and then must figure out how it can be used to improve something. Deborah Chung is one such innovator.
I was really the oddball in concrete research community.
Chung is an NSF-funded scientist at the State University of New York at Buffalo, with an expertise in composite materials and structural science. At her lab, Chung wondered what would happen if she added a new material to concrete: carbon fibers, a material that conducts electricity and consists of strands of carbon atoms.
In the very beginning, I was just thinking of trying to use carbon fiber in a different beast, namely cement.
In early tests, Chung discovered that if she added carbon fibers to concrete, the electrical properties of the structure would change. The fibers don't need to touch. Instead, their contact with the hardened cement allows the entire structure to conduct electricity.
The fibers can greatly affect the electrical properties, not only making it more conductive, but making it able to have its electrical resistance change in response to damage or deformation. And that makes the concrete a sensor.
This also makes concrete structures that are smart, able to detect even minute changes in the amount of stress inside them. Having made the discovery, Chung wondered if it might help tackle a major problem that engineers like Petricca face when building with concrete: the need to regularly monitor structures for signs of cracking or stress.
Typically, historically, it's through inspection, and you're looking for the crack after the fact.
What's really needed is some automatic way that you can monitor that in real time.
As this experiment demonstrates, by attaching a meter to a sample of concrete, Chung can measure the precise amount that the smart concrete deforms as a hydraulic press clenches down on it.
We are increasing the amount of deformation step by step, and that's why the resistance decrease, which occurs every time we compress.
As the slab is compressed, the electrical properties of the sample changes, causing it to become slightly more conductive as the electrical resistance decreases.
The quality of the touching between the fiber and the cement matters a great deal to how effective the fiber is in influencing the conductivity of the entire stuff.
At 10,000 pounds of pressure, about as heavy as a full-grown elephant, the sample finally cracks. With the ability to monitor the hidden stresses inside concrete, Chung says smart concrete may be able to lead engineers to trouble spots in their structures long before a crack is ever visible to the human eye.
Well, after I realized that this resistance change is so sensitive a sensor, that there's something in it that's valuable.
Realizing the value of her discovery, Chung took an important step to protect the idea by filing a patent application at the U.S. Patent and Trademark Office. In 1998, she was granted a patent for what is referred to as a composite material strain stress sensor, or what Chung likes to call smart concrete. While smart concrete has not yet made it to market, engineers like Rick Petricca say such innovations would be welcome.
Those things that we can use to detect things that we can't see are really innovative.
More than just a breakthrough, the discovery of smart concrete is an example of how modern technology, combined with an innovative approach, can enhance a material that has been used for centuries.